If there was life on the red planet, it hit the rocks. Literally, Mars is dry, frozen and arid because its water reserves dried up. A large chunk of that water was lost where the planet's magnetic field collapsed and it could no longer shield itself from the energetic solar rays. On top of this, research out this week shows that a portion of that liquid was absorbed by its rocks, too. How exactly Mars turned into the dust world we see today fascinates scientists. The idea that the water disappeared into space via a process known as photolysis, where sunlight separates the oxygen and hydrogen bonds, has been suggested for a while. When the Martian magnetic field weakened, the sun's rays could penetrate deeper, destroying more and more water molecules. But that's not the whole story, as a group of physicists discovered when studying how the minerals in the planet's rocks interact with liquid water. Their model, published in Nature, takes into account the rock temperature, subsurface pressure, and content, and revealed that basalt rocks on Mars act like sponges, sucking in water. In fact, the basalt rocks on Mars can hold approximately 25% more water than those on Earth. Our calculations suggest that in excess of 9% by volume of the Martian mantle may contain hydrous mineral species as a consequence of surface reactions, compared to about 4% by volume of Earth's mantle, the paper stated. John Wade, a research fellow at the British Natural Environment Research Council at the University of Oxford, said minerals could be key to why Mars is uninhabitable. People have thought about this question for a long time, but never tested the theory of the water being absorbed as a result of simple rock reactions. Wade said, Martian meteorites are chemically reduced compared to the surface rocks, and compositionally look very different. One reason for this, and why Mars lost all of its water, could be in its mineralogy. Luckily, the mineral makeup of Earth is different, allowing it to keep water. Wade said this was down to the fact that Mars is smaller, further away from the Sun, and has more iron in its mantle. These are only subtle distinctions, but they cause significant effects that, over time, add up. They made the surface of Mars more prone to reaction with surface water and able to form minerals that contain water. Because of these factors, the planet's geological chemistry naturally drags water down into the mantle, whereas on early Earth hydrated rocks tended to float until they dehydrate, he concluded. Registered sign.